Okay, I think we'll go ahead and get started. Good afternoon, good morning, good evening, wherever you are. Thanks for joining. Today's topic is managing data for your MRI, your major research instrument, using Globus. And I'm Vas Vasiliadis with the University of Chicago with the Globus team. So before I talk about data management specifically, it was kind of interesting for me to look back at the history of the MRI award program. And it became pretty obvious that the NSF is funding more and more of these major research instruments. And we've seen that sort of anecdotally in talking with the many hundreds of research institutions that we deal with. But this is, you can see here a summary of the awards by year. We've got 77 so far this year that I could find. But it seems to be averaging around 150-ish, which is a fair amount when you think about the different types of instruments. So not only is the number growing, but the diversity of instruments being funded is also growing. So we've got a lot of things like next-gen sequencers, MRIs, functional MRIs, people using NMR for various analyses. Cryo-EM is really the one that we've seen sort of exploding in the last couple of years. So lots and lots of grants for these sorts of instruments. And even more sort of what I would think of as non-traditional instruments, things like major archival systems for the community. So I was actually talking with Henry Newman at Oklahoma this morning, and he has an MRI award and is in the process of building one such archival system for use by anyone that qualifies. And so we're seeing this growing diversity. And if you look closely at some of these pictures, in the bottom right corner under the microscope or on top of the next-gen sequences, you'll see these servers, these computers. So all of these instruments obviously have some type of attached compute and storage, and that's because there's a common thread here, which is the data volumes and the velocity of the data being generated continue to increase. This is just sort of a snapshot of typical MRI, cryo-EM, a cryo-electron microscope. Just a few years ago, sort of 2 to 3 terabytes, or sort of on the high end if you're operating one of these instruments 24 hours a day. It's now above 5 terabytes, depending on the instrument and the resolution. And these things continue to grow. So we've seen almost a doubling in just 3 or 4 years. On a different scale, some of the larger instruments like the advanced photon source or the advanced light source at Berkeley Lab, the APS here at Argonne, where I have a joint appointment, has substantially redone their beam lines to increase the resolution by 3 or 4 orders of magnitude. I'm sorry, the data volumes are going to increase by 3 or 4 orders of magnitude. So it's pretty obvious to see that we've got a little bit of a challenge on our hands, and we really have to figure out how to effectively manage data in these sorts of environments. So the one most common sort of the baseline requirement for a lot of these instruments is being able to move data off the instrument to some other source and be able to do that as fast as possible, but at the same time maintaining data integrity, because as most of you know, some of these experiments that get run on these instruments are very difficult, if not impossible, to replicate. So you sort of get one shot at it, and you have to make sure that the data coming off there land up wherever it may be, wherever they're going to be analyzed. It could be a laptop. That's probably not very common nowadays, given the size of data. It might be a workstation class machine, or more commonly some sort of lab server or set of servers in the lab. But increasingly, people are turning to advanced computing centers, research computing centers on campus with large clusters, and also bursting out to the cloud. And even beyond that, scaling out to some of the national computing services providers, some of the supercomputing centers, and so on. So being able to get your data from the instrument to wherever for compute is kind of critical. So it's sort of a starting point. And so in that respect, we've been doing this at Globus for a very long time. We can certainly do it fast. This is just one sample of moving data between two systems, roughly halfway across the country here in the US. And security is paramount. So we're very careful to avoid having any user credentials in the Globus system. So we typically require that your institution manages access to that instrument, to the storage attached to that instrument. We're simply the broker of using the identities of your users to help them move data to and from those instruments. The data, we never see the data being moved, actually. That's always between the instrument and whatever system it's being sent to. We provide the integrity checking. As I said, that's kind of critical aspect of the transfer. And we have a service that's highly available, so that if you do run these instruments, as many centers are, if you do run them essentially 24/7, you can depend on the service being there to sort of pull data off those instruments and make the instrument available for the next experiment or the next run, or what have you. The other thing that's a big requirement is being able to share data from, maybe not from the instrument itself, but from some intermediate storage where the output data has been moved to. And doing that through Globus is really trivial because you can set the permissions in Globus. You don't have to worry about creating custom temporary accounts or moving the data to some other third-party storage or cloud storage just for the purposes of sharing. So you can share it directly in place from that campus cluster or that lab server or wherever you're doing the analysis. Your collaborators can come along, log in via Globus, access that data, and then use Globus to transfer it to their local system. The third piece is just as important, but more so on the tail end of a lot of projects, which is to make some of the products of the research, some of the artifacts available to the broader community. So whether it's reference data sets or results that can be shared with others in your discipline, having some means of publishing them and making them available through ideally a website where others can show up and search and discover data, and then again using Globus, transfer it to their systems, all without having to set up special accounts or do anything sort of fancy on their end and messing around with technology just to get access to some data set. So for all of these scenarios, we do have services that we built at Globus, and they're being used extensively in the types of instruments that I showed earlier, as well as some other sort of more esoteric cases. And for some folks, they use our web app. We have a browser application that you log in with your browser, and you can point and click and move data and share data and do the things I just talked about. But that's really, it's okay for ad hoc use, but it really has limitations when you start, again, dealing with the data volumes that we're all becoming accustomed to. So at a minimum, being able to move data on a recurring basis is required. So we have a timer service that allows you to schedule transfers. So if you have certain time windows during which the instrument is operating, and then that each one of those time blocks perhaps is allocated to a different experiment or different sample, what have you, you can schedule transfers to run on a recurring basis at on the hour, every day, every what have you, move data to some staging area. So that's one aspect of sort of simple automation. In other cases, you might actually want a little bit more control around this automation. So you may use the Globus command line interface. So we have a full-featured set of tools on the command line that you can build into your own scripts. So you could initiate a transfer, you could put data somewhere and allow it to be shared with others. You could set the permissions appropriately so that only certain users or groups of users can have access to it, and you can notify them that data is available and so on. So you can do this, and it sort of gives you another level of scale in your automation. Another common scenario here is being able to stage data for compute. So you may have a script that pulls data off the instrument, puts it as part of a staging command to run some high throughput computing or other job on some resource, and then put stage out. The stage out command might actually put the data elsewhere for you to look at and analyze further. So that sort of progressively you can automate more and more of this end-to-end process and do it at increasingly higher scales. And sort of at the end of this continuum, or further down this continuum, we also have a service called the flows service, which is really for larger scale automation, where you can define more complex flows of data, which may include not just transfers and sharing and so on, but they may include computation, they may include describing data with the addition of metadata to create search indexes, and so on. And these flows are things that you can define. You can have someone define a flow and then make it available to anyone to run, or to a select group of users. Again, all of these things that I'm talking about have a permissions and access control infrastructure wrapped around them, such that you can determine who has access, who has administrator level access, end user access, and so on. So these flows can be constructed to do arbitrarily complex or simple things using what we call action providers. So you have interfaces to other services where you can take action. So a file transfer may be an action. The ingest into an index, a search index, may be an action. The minting of a persistent identifier like a DOI may be an action, and attaching that to the data is another action, and so on. So that's this is actually a service that we recently put into production, and are encouraging folks to use it. An example of where this is being used very effectively at very large scale is on one of the advanced photon source beamlines, where they do XPCS, X-ray photon correlation spectroscopy. So the flow basically automates moving of data from the machine with the acquisition machine on the beamline, pushing that data out to a cluster at the Argonne Leadership Computing Facility, running eigencodes on that to do the image correlation, and then plotting the results, pushing those out to a large-scale storage system, and then describing it, adding metadata, and putting it into a search index that then allows people to come along and find the data. So from a sort of a high-level flow perspective, the flow has these different steps. As I said, there's always some fine-grained level of authorization to determine who can access this thing, who can do what, and that kicks off flows, compute, search, and so on. And this is just a couple of screenshots. I don't have time today to do a full walkthrough live demonstration, but there are actually some samples that you can look through in our documentation, and we will soon have some additional flows available for people to run. But this is what it looks like. We define a flow, and then it's available. You can start it. You can also automate the running of these flows again, which is something that more and more folks will do. So and have them triggered when certain things happen on the beamline, on the microscope, what have you. So you may be wondering, okay, that sounds great. How do I get one of these? I'll use this as an opportunity to just very quickly talk about how Globus is architected. Some of you, looking at the names, I see some folks are probably very familiar with this, but for those that don't know Globus, the way it works is we operate a single cloud-hosted service. We run it all on Amazon Web Services. and that's shared by all users. What happens is we call this a hybrid software as a service, because you, as the user, will install a piece of software on your instrument storage or some attached storage, that's sort of staging area for the instrument data. That piece of software is called Globus Connect, and that makes your storage system an endpoint, as we call it, so that Globus can see it, and then you can access the data on that endpoint and move it and share it and so on. We also have all these other services that I mentioned around creating search indexes and flows and so on. These are also available to you in the form of APIs that you can integrate into other applications. So you may already have something that's been built specifically for your experiment or for your research area, some existing tooling. These are standard REST type APIs that you can use to add these capabilities into your systems, or build something from scratch. And we also have a number of examples of how people have done that. But again, the first step is to make your system accessible via Globus using Globus Connect. For some systems, you would have to use Globus Connect Personal. For instance, a lot of the captured devices on the instruments are Windows-based. So we don't support Windows Server, so you would install Globus Connect Personal, and there are ways to structure that so that it can operate in the mode I was describing earlier. Alternatively, you may install Globus Connect Server, and we support a number of diverse storage systems beyond just sort of regular standard POSIX compliant file systems. These systems that I'm listing here, most of these require a paid subscription. So just moving data off a standard POSIX file system, that's something that you can do at no cost if you're a nonprofit research institution. We do have commercial customers, and they actually have to subscribe to use it. But if you're a nonprofit, you can move data without paying anything. But if you want to access any of these other types of systems, or put your data perhaps on some cloud storage or into an archive or something, you would need a subscription so that you can use one of these connectors, as we call them. There are also some cases where you may have requirements around managing data according to certain regulations, either because it's PHI or somehow restricted or protected. And so in that case, you can use our high assurance layer, which provides additional security aspects and features. We even can go as far as signing a BAA with you if you're managing PHI. So we do have that in place with a lot of healthcare systems and the medical schools and so on. And these are all, again, paid subscription features. The subscription also gives you a lot more visibility as a system administrator, so you can monitor what's going on in your environment in real time. You can get historical reporting and see, who's doing what, who's moving what, who's sharing what, and so on. So I talked about this sort of freemium model. You can use transfer free, or you can subscribe. I do need to clarify, for those again that are not familiar, who Globus is. We're actually a nonprofit service at the University of Chicago, so we operate this service on behalf of the community, but we do try and do that in a sustainable manner. So we want to help all researchers, but we want to be around for the long term to run essentially a production grade service that we've been running for almost 11 years now. So we have this model where you can subscribe. We do have a large and growing installed base. You can see some snapshot of the numbers here. And so we hope that if you do use the service, that you will support us. We get most of our development funding from the usual agencies that many of you also work with. But we, as I said, we do rely primarily on our subscribers to fund the operations. So hopefully you would see the value in using some of the more advanced services that I talked about and become a subscriber yourself. I'm going to, we're a little after 20 past, so I'm going to pause there. Here are some links. Again, this is being recorded, so you're welcome to refer back to it. We'll have it posted on our YouTube channel shortly. We do have a lot of documentation, a lot of sample code out on GitHub, all open source code that you can use to access some of the platform services I mentioned. With that, I'll open it up to questions. You're welcome to raise your virtual hand or ask to be unmuted, and I will allow you to talk as Zoom says here. And I see you also have some questions in the chat, so I can open that up and see. I see Greg's been answering some of those. So any questions? I see one. Okay, Greg, I think, has handled those. Globus timer. Okay, yeah. Does anybody have a question? You can raise your hand by clicking on your name. Okay, so Ken Ho, go ahead. You can unmute and ask.
Hi, thank you very much for a very interesting talk. Sorry, I'm aware of Globus, but haven't used it myself. But just wondering about, is it possible, because basically, as you have mentioned, that we create tons and tons of data every day. Instead of moving them, is it possible to remote access them by a kind of API, such that you're basically running applications, but the data actually is remotely through the service?
So if you're asking, if I sort of interpret that as
so in a more concrete one, I'm working with I don't know whether you're aware of imaging database, Omero or whatever. Okay. Just wondering whether you can have the data actually reside in different institutes, but I have one server to actually visualize it through different sites on different data sets.
Okay, yeah. So so in that environment, so we don't provide any sort of direct remote access, if you will. So it's not like you can almost in a sense remote mount that data onto your system and do something with it. You would have to move it to wherever you're going to analyze it and visualize it and do it there. So Globus essentially is more the underlying infrastructure for enabling some of these things. We're not necessarily the final end user tool that you do visualization or browsing with.
Yeah. Okay. Thank you.
Sure. Masashi Watanabe, go ahead.
Hi. Yeah. Thank you. That's a very nice question. Very nice talk. I really enjoyed. So my question is how to handle properly, efficiently about the metadata. So we have so many different type of instrument, then always metadata handling is always issue. So how flexible or how automated?
Yeah, so that's a great question. So I mentioned this this search service that we have, Globus Search, and you can ingest metadata into that. Because we don't impose or require any type of specific metadata schema or ontology or anything like that. What we essentially leave it up to you. We have very simple APIs that you can call. As long as you push the data in a certain format, in a JSON format that's well described, you can automate that by essentially running a script that generates that, extracts the data from your files or from the file system or whatever it is, the various facets that you want to index, and then just call Globus Search and ingest it, and we'll take care of indexing it and keeping that index current, and then you can use the same API to query it. Okay, so do you use the automation on the front end of getting the data in there? We leave up to you, because again, everybody's situation is potentially very, very different in terms of what data, where it's coming from, the format of the files, and so on. What can be automatically extracted versus manually, and so on. Right.
So is it HDF5 type of system or different?
We actually, funny you should mention that. So we have a lot of requests to do some additional things with HDF5. So right now we just treat HDF5 as at the file level, because that's really how we view essentially all data sets as file objects. The sort of introspecting the HDF5 structure and pulling data out, we don't have that, but that's actually something that's been asked about a lot. So I expect that will be something that we do at some point in the future.
Okay, yeah. Thank you.
Sure. Other questions? I see more in the chat. Greg, let me know if there's anything you want me to answer live.
No, I think I've covered everything in chat. I did see there is one in Q&A though. I was watching chat and not watching Q&A.
Okay, there we go. Okay, yeah, there's a lot of channels here. Can we have multiple Globus Connect Personal sites, i.e. at work and at home? Yes, so you can install Globus Connect Personal on as many systems as you wish. One thing to be aware of is that if you're moving between two personal endpoints, that does require a paid subscription. If you're moving from a server to an endpoint or from a personal endpoint or vice versa, as long as there's a server on one end, you don't need that subscription. But the personal to personal is one of the premium features. Anyone else? Feel free to raise your hand and I'll unmute you. Yes, Jacob, go ahead. Jacob, did you have a question? You can unmute, and I think you're still muted.
Oh, okay. Yeah. Can you hear me now?
Yes.
Yeah, I think so. So I'm wondering how you can use the Globus Connect Personal to on an attached instrument to allow people to move data off the instrument. I'm thinking here of an instrument where a multi-user instrument, for example, if it has a window, it's a little bit fuzzy to me how you will set up a directory where the Globus Connect Personal can read, or whether you can set it up in a way that everybody logging in can just have access to a shared directory, but they can have their own Globus Connect Personal. Is that possible?
Yeah, so you mentioned a couple different ways. So the more common one I would say is installing Globus Connect Personal, creating a shared collection, as we call it. And so you can have the structure automatically created with the instrument, the capture software is creating some structure. You can have it put that structure inside of the shared collection automatically. And then you can decide who has access to it. You can use a shared account. The only requirement really is that you need Globus Connect Globus Connect Personal to be running. So there needs to be a user. So some groups will create a service account and be logged in with that, run Globus Connect Personal, and then use a shared collection so that users don't have to log in with their own accounts to access that.
So if the instrument is a multi-user instrument, yeah. I'm just wondering how. So you install Globus Connect Personal to be universally accessible, and anybody can now set their own directory, because I think you have to configure the Globus Connect Personal and tell where it has to read. Then when somebody logs in, do they have to point their directory, specify their shared directory, or is there a way you can set it up in a way that they just log in and don't?
Yeah, you're right. There is. So Globus Connect Personal is tied to an account. So if you wanted to have to a Globus identity, basically. So if you wanted to have every user with their own Globus Connect Personal, that's not going to work on the same machine. So yeah, the way you described, which is you have a shared Globus Connect Personal, again, something that was created by by a service account, and then you can, using directory permissions, you can allow different users to access different directories on that device. And again, ideally, you would create you could create a shared collection on each directory. So then users, when they go into the Globus web app, they'll see just their shared collection.
Okay, thank you.
Sure. Anything else? We're just a little past time, but I'm happy to stick around and answer any more questions. I see there's Globus support integration with LDAP. Yeah, so we're essentially agnostic to what you use sort of on the back end for authentication, identity management. Mostly, we just require an OpenID Connect endpoint. So most servers out there, LDAP and others can expose an OpenID Connect endpoint, so you can you can use that for authentication. Yep. Okay, anything else? Okay, I see a question. Greg, you answered that one about global transport.
You might just want to speak to Globus usage worldwide.
Yeah. So yeah. So as far as just to sort of clarify in case there's perhaps confusion on the architecture. So we Globus don't have any of these endpoints that I've been talking about. These are all endpoints that are managed by the owners of the respective systems. So as I showed on that one slide with all the bubble numbers, there's tens of thousands of systems out there that have Globus deployed. All of those are managed independently by their owners. We have no sort of direct connection to them. We simply act as the broker of the data movement or the permissions, the access control that people are sharing, and so on. And we are, again, completely agnostic as to where those systems live. Or we're not agnostic. We don't particularly care. We know where they are because we have to talk to them. But there's no requirement that systems be in a certain geography, as long as there is a network route that can be established between those two systems to move the data. And as long as both systems are, both the endpoints are accessible via public route for us from the control service, from the Globus control service, so we can manage that transfer or that sharing, permission setting, and so on. It doesn't really matter where they're actually physically located. So I hope that answers the question, but feel free to raise your hand and I'll unmute you. You can discuss it further. Okay, so if there are no more questions, last call. I would like to thank everybody for joining us. Thank you again. We are going to record and publish this shortly. And if you have any questions, please feel free to reach out. We're also making ourselves available, I should say, to consult with anyone that wants to sort of explore some of the different use cases or the best practices for deploying Globus in the context of managing instrument data. We've done this with a lot of different groups, so there's no cost to it. You're just welcome to reach out to myself or just email support@Globus or outreach@Globus. All of those will get our attention, and we can set up time and talk about your specific use case.